कि last time मैंने कहा था कि I told you that the octet rule, ठीक है, this octet rule, it's only applicable to shell number 2 elements, जो कि period 2 elements है, because they have a maximum number of 8 electrons. When you come to shell number 3, the maximum number of electrons, जो है, that could be greater than 3. ठीक है, it could be 18 as well. So we discussed that. So if you have chlorine, so chlorine's outer shell has 3 subshells. It's got a 3s, a 3p, and a 3d. The 3p needs 1 electron. The 3d is completely empty. So I told you that there is an extra space available for 10 electrons at its outer shell. एक यहाँ पे, so that's a total of 11 electrons. So chlorine can gain or share a lot more electrons, and it can make a number of bonds. So it has variable oxidation states. So ये example था कि ClO3 -1, where Cl's outer shell, 2 over here, 4 over here, 4 over here, 2 over here, that's a total of 12 electrons. So Cl has 12 electrons. It can have a maximum of 18 electrons. So वो मैंने example किया था, और so I told you there was a thing called octet expansion. For bigger atoms, it's easier to make more bonds. ठीक है, smaller atoms, they hold their electrons very tightly together. So like in bigger atoms, they tend to share more electrons. Why? Because the electrons are really far away. So if fluorine needs electrons, this iodine atom is not in the first place, it's not attracting that electron very strongly. तो वो fluorine के साथ share कर देगा, ठीक है. There's another fluorine that's trying to gain this electron, so it will try to share an electron with that fluorine as well. So bigger atoms, they've got bigger shells, which is why they're able to distribute electrons a lot more compared to smaller atoms. Smaller atoms होते हैं, they're tightly holding on to the electrons, so they tend to not make that many bonds. So ये हमने discuss किया था. So I just told you that be aware of the fact कि period 3 elements, period 4 elements, और उससे आगे जितने भी elements हैं, they will tend to make or have more than 8 electrons in the outer shell. ठीक है, ये clear है बात?
Yes.
So जो अगली चीज करनी है, that's the next thing is shapes of molecules. I told you that you've got a number of molecules. Now we're going to discuss. What we're going to discuss is shapes. Remember, we're sticking to covalent molecules. So that's the next thing we're discussing: shapes of covalent, shapes of molecules. There's a theory which is known as the valence shell electron pair repulsion theory. Okay, so valence shell, basically that means that valence shell electrons, they repel each other. So electron pair valence shell electron pair repulsion. Or वो है क्या? What does it state? It states that if you've got bonds, as in valence shell, you'll have a lot of things. You'll have bonds, you'll have lone pairs. So for example, if I have a water molecule, okay, let's try with a simple one. Okay? So I mean, let's talk about the water molecule. So if I've got a water molecule, the water has an oxygen, and it's got 2 hydrogens that are bonded to it. So oxygen has 6 electrons in its outer shell. Now remember, oxygen is a period 2 element, so octet rule applies to it. Okay? The maximum electrons that it can have is 8. It can't have more than 8 electrons. और यहाँ पे hydrogen बैठा हुआ है, so hydrogen has just 1 electron. So oxygen will try to attract that electron, and this hydrogen will not be losing electrons. वो पूरा का पूरा, the whole hydrogen atom will come along and they will start sharing electrons. Okay, so that's one bond, and oxygen needs another electron. So there's going to be another. So there's going to be another hydrogen atom, and this hydrogen atom will also share electrons. Okay, with oxygen. So if you look at oxygen, though, it's got the oxygen atom in it and its outer shell. Remember, we were talking about the valence shell. So the oxygen atom has bonds. So they are bonded electrons, and it's got lone pairs as well. Okay, so it's got pairs of electrons in its outer shell that are not involved in bonding. Okay, so you've got bonded electrons and you've got lone pairs. So let's say that's your bonded electron, and here's another bond. Okay, तो मैं इस तरह show कर रहा हूँ. ठीक है, same thing. So if you look over here, what the valence shell electron pair repulsion theory states is, okay, all of them are actually repelling each other. I mean, this bonded electron over here, they are repelling the electrons in the other bond, okay, because electrons, they repel each other. And the lone pairs over here and the lone pairs over here, they're all repelling each other. नहीं, octet rule ये था कि Zabiba, I told you that elements tend to complete their outer shell electrons, right? Covalent bonding mein they complete the octets, right? So yesterday I told you that the octet rule is only applicable to shell number 2. That is, shell number 2 elements, period 2 elements, the maximum number of electrons that they can have in the outer shell is 8. When it comes to shell number 3, the maximum number of electrons that they can have is a lot more than 8. They can have 18 electrons. So when it comes to bonding, chlorine can form a number of bonds. It's not limited to you remember in O levels that chlorine only gains 1 electron, or it only makes 1 bond because it needs 1 electron. It's a group 17 element, but in fact, chlorine can have a maximum of 18 electrons. So it can make a lot more than 1 bond. It can accommodate this space available for 11 electrons. Zabiba, is this point clear? हमने कल discuss किया था कि I told you that. So period 3 elements and onwards, right? It's you can have a lot more electrons. I say, anyways, valence electron pair repulsion theory. Okay, we want to figure out the shape. So the point is, these lone pairs. Okay, remember these are lone pairs. वो लिख भी देता हूँ. अच्छा, this is one lone pair. This one is another one lone pair. So it's got 2 lone pairs. Lone pairs not doing anything in the outer shell. This one is a bonded pair. So bonded pair of electrons, that's another bonded pair of electrons. So they're all trying to repel each other, and they will, in 3-dimensional space, they'll try to be as far away from each other as possible. This will repel this one. This one will repel this one. This one will repel this one. So imagine, Karo, you've got, imagine that all these electrons in over here, they will try to be as far away from each other in 3-dimensional space, not in 2-dimensional space. They will try to be as far away from each other as possible. और इसके अंदर ये याद रखना कि these lone pairs, they exert a greater repulsion. So lone pairs exert a greater repulsion compared to bonded pairs of electrons. The कौन सी चीज है? The pairs are repelling. It's electrons, they always exist in pair. We'll talk about them in orbitals, but what is happening is you've got a pair of electrons, you've got a pair of electrons over here that's being shared, that's a bonded pair. You got a lone pair over here, you got a lone pair over here. They'll try to be as far away from each other as possible. ये मैंने उस circle के बगैर draw कर लिया, ठीक है? So they will try to be, all four of them will try to be as far away from each other as possible. The lone pairs are these ones. They're electrons in the outer shell that are not doing anything, that are not involved in bonding. And bonded pairs are electrons that are involved in bonding. I mean, that's the difference. It's is this clear? कि difference के इन चारों में. So what I'm stating is electrons repel other electrons, right? So if there's a pair of electrons, it will repel the pair of electrons over here. It will repel the pair of electrons over here. It will repel the pair of electrons over here. So they're all trying to repel each other. And remember this, that lone pairs have more repulsion. They exert more repulsion. So lone pair repulsion is greater than bonded pair repulsion. And there's a reason for that. As a reason is that lone pairs are like really close to the atom. Bonded pairs are electrons that are being attracted by some other atom, so they're kind of far away. जब आप दूर होते हो तो obviously the repulsion is going to decrease. ठीक है, this bonded pair, hydrogen is pulling those or attracting those electrons. So bonded pair of electrons are kind of further away from the atom. So if you go far away, then the repulsion decreases. So because lone pairs are like really close to the atom, and bonded pairs are kind of slightly further away because they're attracted by another atom. तो वो दूर होने की वजह से ना, they're further away. That's why the repulsion or the amount of repulsion that they can exert decreases. Is that clear? ये बात clear है?
Yeah.
Zabiba, is this clear? So I'll do the first example. Okay, there are a number of scenarios. It's between electron. Like you have a single atom. So we're trying to determine the shape. So you've got a single atom. Let's say you've got an oxygen atom. So I'm just focusing on the oxygen atom. The oxygen atom has electrons around it, and all those electrons are trying to repel each other. Okay, it's simple. Like it's got electrons over here. It's got electrons over here. It's got a bonded electron over here, pair of electron. A bonded pair of electrons over here. They're all trying to repel each other. That's the simple idea. So we will example karte hain. I'll show you the first example. So you'll have different molecules. So let's talk about the first example, and we're going to try and predict what the shape is going to be. So if you've got two bonded pairs in a molecule, just two bonded pairs. An example is कि अगर beryllium को देखो ना, beryllium just has two electrons in its outer shell. So when you talk about beryllium, it's got two electrons on either ends. So it usually forms just two bonds. So when you make beryllium fluoride, it's like this, that there is beryllium, and there's going to be one bond over here, and there's going to be another bond on the other side. There's going to be fluorine bonded over here, and there's going to be fluorine bonded over here. So there's going to be a pair of electrons over here and a pair of electrons over here, and there will be no lone pairs, nothing. That's it. Okay. And remember, the shape of the molecule is determined by the atom that's right in the middle. Okay, that's the one that's going to determine the shape. So what is going to happen? What is going to happen is these bonded electrons over here and these bonded electrons over here, they will try to repel each other. They will try to be as far away from each other as possible. ये वाले electrons, they want to be as far away from these electrons over here. They repel each other. So the only way that is possible is if one pair of electrons is on one side and the other pair of electrons is on the complete opposite side. But they've got different scenarios, like ये भी हो सकता था कि this one, this fluorine over here might be bonded to like this, right? But this pair of electrons and this pair of electrons want to be as far away from each other as possible. अगर वो बहुत dono bonds, if they are very close to each other, like this, then obviously that's, I mean, there's going to be too much repulsion. Okay, so the shape of the molecule is going to be such, if one pair of bond is on one side, the other one is going to be on the complete 180-degree opposite side. Okay, it's going to be on the, it's going to be on the complete opposite end. Is that clear? The idea clear?
जी sir.
So that is known as a linear shape. Like the atoms would be in a straight line. So this is a linear shape, and the angle or bond angle is going to be 180 degrees. Okay, so this one did not have any lone pairs around beryllium. And remember, it's you can see that. Actually, it's just this K. I was saying that if you have, I was saying that you always look for the middle atom. That's going to determine shape. Now, this beryllium has no lone pairs. There are no other electrons. There's just a pair of bonds over here and a pair of electrons, bonded electrons over here. These electrons over here and these electrons over here, they will repel each other. Ye yahan pe, and they're going to maximum, I mean, they will exert maximum repulsion on each other. So they won't be close to each other. मतलब इसको अगर हम इस तरह draw करते हैं, तो the bonds would not be like this, because these electrons over here and these electrons over here, they will try to be as far away from each other as possible. So the only best scenario is that one pair of electrons is one bond is on one side, the other bond is on the complete opposite side, and the atoms will be in a straight line. Okay, so the actual shape of the molecule would be like this. One beryllium, fluorine will be bonded on one side, the other fluorine will be bonded on the extreme opposite side. ये वाले electrons and ये वाले electrons, they will try to repel each other. ठीक है, so Viva, is this clear? And that's going to be the shape of the molecule. It's going to be, I'll show you the shape. Okay. So shape of molecule, मतलब वो models होते हैं, so they'll अच्छा, इसको हम सामने रख लेते हैं इस चीज को. So that's, I mean, it's going to be exactly like this. It's going to be 180 degrees, and it's going to be linear. One atom, the other atom is over here, the other atom is over here. That's it. Okay, that's a linear shape. अच्छा, वापस इस पे आ जाओ. अच्छा, there are other examples as well. Carbon dioxide is the same. So when I talk about bonded pair, I count triple bond as one bonded pair. Okay, so for example, if I've got carbon dioxide is kind of similar. It's got a double bond on one side and it's got a double bond on the other side as well. The two double bonds will try to be as far away from each other as possible. So that is also going to be linear. And it's going to be, so it's got two bonded pairs. It's got a pair. So remember, double bond, think of them as one thing. A bunch of electrons, bonded electrons, they're all together, even though it's a double bond. There's a bunch of electrons over here, even though that's more than two electrons, but think of them as one thing. ठीक है, तो उसको भी two bonded pairs consider करना. A pair over here, a bunch over here, so that's two pairs. If I've got another molecule like HCN, that's going to be similar. It's HCN is H bonded to C, and then that C further on makes a triple bond. So think of the triple bond as one thing. So you got a bunch of electrons over here, you got a bunch of electrons over here. The two pairs will try to be as far away from each other as possible. So the triple bond will be on this side, 180 degree opposite, there's going to be the other bond. So all these molecules are linear. Is that clear? Or keep this in mind, okay? Think of double bond as one thing. One bunch over here, one bunch over here. They'll try to be as far away from each other as possible. Is that clear?
जी sir.
As a second part, what if you have three bonded pairs? So you got a molecule, और ये second का ना A part कर लेते हैं, ठीक है? So you got, अच्छा, so you got three bonded pairs. So what will happen in this case? That's going to be fan shaped. An example of three bonded pairs is you've got AlCl3. Now AlCl3 के अंदर they're just three bonds. So you've got one bond with Cl, you've got another bond with Cl, and you've got another bond with Cl. So you got three bonds, that's it. So there's going to be a pair of electrons over here, एक pair of electrons यहाँ पे, and there's a pair of electrons over here, and they will be trying to maximally repel each other. So the only scenario is, so the only scenario is that they will be 120 degrees from each other, and shape क्या होगी? That's known as trigonal planar. So it's trigonal planar, and the bond angle is going to be 120 degrees. So in three-dimensional space, it makes a fan. So molecule would look like a fan.
So how will you write the bonded pair for double bonds
इसमें
in double bonds? How will you write the bonded pairs like you write over here?
नहीं, right किस तरह के नहीं लिख
The
सकते?
electron.
There are four electrons over here. There's four electrons over here as well. What I was just saying is, think of double bonds as one thing. Like, don't think of it as two bonded pairs. Think of it as one pair, or don't even think of it as one pair.
Repulsion or attraction between the two bonds.
इसमें इन दोनों के बीच में, अच्छा,
Yes.
ये कह रहे हो ना कि will there be a repulsion between this and this, right?
Yes.
अच्छा, there's going to be repulsion. वो हम detail में पढ़ेंगे. But the thing is that the electrons are still together because the bond is between oxygen and carbon, right? So even if there is repulsion, so they might be far away, but they'll be still together at this point. The idea clear? Because the bond is between the two atoms, right? We'll discuss how double bonds are actually formed later on. Like, at least the electrons are still together. Even if they are repelling each other, they might be slightly far apart, but at least they will be together, right? Is that clear? उसको आप एक ही group
So what thing keeps it together?
अभी
What
simple.
thing keeps it?
अच्छा, what thing keeps them together? That's because there's a nucleus over here and there's a nucleus over here. Both nuclei are attracting each other, right? So मतलब double bond is बनता है ना? This is how a double bond forms. Like you have this is what a double bond is. There are four electrons, and the four electrons are stuck between two nuclei, right, on either side. ये वाला nuclei इस side पे खींच रहे हैं उनको. This one, these ones are pulling over here, right? So the electrons are kind of stuck in the middle, right? So it's the nucleus of the two atoms. That's what a bond is. Okay, the electrons will be stuck in the middle. So that is how they will be kept together, because एक nucleus this against the other one is, so think of this electron. It's being pulled by this nucleus. It's also being pulled by this nucleus, right? So it's not able to go anywhere. Is that clear?
Yes.
So इसलिए अभी फिलहाल we haven't discussed double bonds in that much detail. We're going to do that later on as well. So अभी फिलहाल just remember, think of these electrons as grouped together, as a bunch of electrons that is together. Think of a double bond as one thing. They're all together. So this bond over here and these electrons over here, they will try to be as far away from each other as possible. So it's going to be 180 degrees. Is that clear?
Yes.
So three bonded pairs be clear. That's trigonal planar, and that's and the bond angle is going to be 120. Okay. और इसमें भी I'll give you examples of other molecules which are trigonal planar that have double bonds. For example, I've got sulfur trioxide. So it will have double bonds. It's going to form a double bond with oxygen. It's also going to form a double bond with another oxygen, and it will form a double bond with another oxygen. Okay, so it's going to be fan shaped, and oxygen. Okay, that's oxygen. There's another oxygen, and there's another oxygen. Okay, so that's also trigonal planar. Achha, how do I
They have
know?
exact angle because of repulsion.
Hmm?
Like three bonded pair have 120 angle. It is because of repulsion, and that one bonded pair has 180 uh, degree.
नहीं, two pairs होंगे ना अगर
Yeah, two pair.
two groups होंगे ना, so they will be as far. I mean, they'll try to be
It
as
is
far.
because of
Repulsion.
repulsion, that exact angle.
Okay, this one is repelling this one, right? So they'll try to be as far away from each other, right? Is that clear? So when you have
Yeah.
when you have three bonded pairs, they'll try to be as far away from each other as possible. And the only way in three-dimensional space that they can be actually far away from each other is it's trigonal planar. It's 120 degrees. If they are 120 degrees away from each other, is that clear?
Yes.
Acha, or sulfur, you be clear on this one. That you've got a
Yes.
bunch of electrons here, here, and here. So that's three pairs or three groups of electrons, and they will be as far away from each other as possible. Acha, how do I know that there is no lone pair? Okay, I remember bonds का तो पता लग जाता है. How do I know that there are no lone pairs? The way you know that there is no lone pair is aluminium is group 3. That means it's got 3 valence electrons. One electron involved over here, one over here, one over here. So there is no electron left. Okay, so there is no lone pair. Similarly, sulfur. Sulfur is group 6. Group 6 means that it has 6 valence electrons. 2 electrons involved in bonding over here, 2 of them involved in bonding over here, and 2 of them involved in bonding over here. So पीछे कुछ भी नहीं बचा, ठीक है? So all 6 electrons have been used up. But sometimes what will happen is that there's going to be another variant of this, and that is that it will have lone pairs. So 2-part B जो है ना, that is as a 2-part B. It's going to be you have 2 bonded pairs. So total pairs अभी भी 3 हैं. You'll have 2 bonded pairs plus you'll have 1. So you'll have 1 lone pair. I said 2 bonded pairs plus 1. I said plus 1 lone pair. I said what happens in this scenario? One example is I've got sulfur dioxide. Sulfur dioxide के अंदर ना you've got sulfur making double bonds with oxygen. That's a sulfur making double bonds with oxygen. And on one side, मैंने क्या कहा था कि how do I, now that's it, sulfur, that's the bonding of sulfur in sulfur dioxide. It's making 2 double bonds. Are there any other electrons left in the valence shell of sulfur? Okay, sulfur is a group 6 element. That means it's got 6 valence electrons. 2 of them got used up in this bond, 2 of them got used up over here. So 2 bach gaya na. So that means it's got a lone pair over here. Now the shape is kind of the same. It's going to be fan shaped. Okay, so it's kind of going to be the same exact shape. There's no difference. It's just that on one side, instead of having a bond or an atom attached, you don't have anything. You just have a pair of electrons. Is that clear? Just the oxygen ka case tha. If you look around the oxygen atom, it's got a pair of bonds over here. It's got a pair of bonds over here. It's on 2 sides. It's got 2 lone pairs, which are electrons in the outer shell that are not involved in bonding. The weak case sulfur dioxide mein, okay, if you look at sulfur dioxide, you'll notice that group 6 ka matlab hai, it's got 6 valence electrons. So 2 electrons shared here, 2 electrons shared here, 2 बच गए. तो clear है कि इसकी shape exactly वही है, right? Is that clear? It's got a bunch of electrons
Yes.
here, a bunch of electrons here, and a bunch of electrons over here. But the problem is that there is no atom attached on this side. So that will not be counted. It's like a fan. मतलब ये fan की तरह है ना. So it's like a fan जिसका एक blade जो है ना, one of the blades of the fan is missing. I mean, the electrons are still there, but there is no atom attached over there. I mean, you've got electrons, and remember lone pair sky, I told you that they were closer to the atom, right? So there's no atom on this side. So the shape of the fan is exactly the shape of the fan, except that one side of the fan is actually missing. तो आप बस imagine करो कि same shape, बस fan का ना एक side को गायब कर दो, ठीक है?
सर
हाँ जी.
ये लोन पेयर और बॉन्ड पेयर में रिपल्शन बॉन्ड पेयर और बॉन्ड पेयर से करके ज्यादा होती है ना.
हाँ.
तो सर शेप वापस नहीं बिगड़ जाएगा कि वो 2 ऑक्सीजन मॉलिक्यूल्स क्लोजर हो जाएंगे.
हाँ. नहीं, कौन से 3? ये वाले 2 की बात कर रहे हो ना, ये और ये.
जी सर.
हाँ, वो मैं उस पर आता हूँ. वो इतना कोई जमीन आसमान का फर्क नहीं होगा, थोड़ा सा क्लोजर हो जाएंगे, ठीक है. बट ये क्लियर है कि जो शेप है ना, इट्स के टॉप साइड इज मिसिंग, ठीक है. यहाँ पे I mean previously there was an oxygen, now there's nothing there, right? So this shape is known as just a bent shape. मतलब how does a fan look like if you just remove one of the plates? It's just bent or V shaped. ये मतलब यहाँ से है और यहाँ से है. I mean there's nothing. वो जो top side थी ना, that's gone because there's no atom attached over there. So this is known as V shaped or it's known as bent. So instead of calling it trigonal planar, which was fan shaped, now it's just called V shaped or bent. अच्छा, plus वो बात ठीक है कि I told you that the lone pairs, because they are closer to the atom, they will repel or they will exert more repulsion. ठीक है, they will exert a greater amount of repulsion. What that will do is कि वो the oxygens will be pushed closer to each other. So these oxygen over here, they will be pushed closer to each other. So the angle over here, previously the angle was 120, but now the angle is going to decrease very slightly. It's going to become somewhere between 117 degrees to 119 degrees. So instead of exactly being 120, it's now going to be slightly lesser. So lone pair exerts greater repulsion. And that's why the bond angle decreases. Or becomes less than 120 degrees. ठीक है, is that clear?
जी सर.
और इसी तरह तीसरे पे आ जाते हैं, the third one. What if you have 4 bonded pairs? ऐसा इसकी भी फिर different versions होंगे. So what if you have 4 bonded pairs and एक second. I mean, they all repel each other, ना? मतलब वही हमने डिस्कस किया था कि they're all trying to, I mean, these are electrons, these are electrons, these are electrons, these are electrons. They all repel each other, except that lone pairs repel more, slightly more. अच्छा, वापस इस पे आ जाते हैं कि you've got 4 bonded pairs. Now, if you have 4 bonded pairs, what will happen in this case? Okay, 4 bonded pairs. और उसका example CH4 का है. What will happen is that that is known as a tetrahedral arrangement, which is that if you have 4 bonded pairs, so the molecule would kind of look like this. That there's going to be hydrogen, hydrogen, yahan pe bhi hydrogen hai aur yahan pe bhi there's hydrogen, right? So it's like all 4 will try to be as far away from each other as possible. So it's like a pyramid, 3-dimensional. ये जो wedge-shaped bond है ना, that's the one that's coming towards you or out of the page, ठीक है? And the dotted one that's going behind you, that's going into the page. So think of the sides of the pyramids, and there's an H that's right on top of the pyramid. It's this shape. It's this tetrahedral shape. This one over here. Or it's 3-dimensional, ठीक है? So which is why it's looking like this. All the angles are exactly the same. So this is tetrahedral, and this one is 109.5 degrees. ठीक है? तो यहाँ पे खत्म करते हैं कि बस ये याद रखना है कि whenever you see a molecule, if you think that it has 2 bonded pairs, then it's going to be linear. If you think it's got 3 bonded pairs, then it's going to be fan-shaped, it's going to be trigonal planar, and it's going to have an angle of 120. If that molecule has 2 bonded pairs and 1 lone pair, then that molecule will be bent or V-shaped, and the angle would be slightly less than 117. And if it's got 4 bonded pairs, then it's going to be tetrahedral. ये आगे जाके पहले सारी shapes discuss कर लेते हैं, फिर we'll do some questions on this. ठीक है? तो कल बात करते हैं. ठीक है?
Okay, sir. Allah Hafiz.
Yeah. Okay. Allah Hafiz.